Hi viewers, welcome to LMS Solution. Today we are going to see about hybrid Fuzzy PSO MPPT for solar PV system. So this model is developed in the MATLAB for hybrid PSO MPPT. So it consists of solar PV and then a boost converter and then load and then it contain a PSO algorithm and then Fuzzy algorithm. So here we are measuring the power and then here we calculate the change in power. Based upon the change in power, the switching will be happen in between PS and Fuzzy. Here we are going to hybrid in the Fuzzy MPPT with the PSO MPPT in order to extract the maximum power from this solar PV panel. Here you can see that this is the model we are used this 200 watts PV panel, and then the open circuit for this panel is around 32.9 volt, and voltage at maximum power point is around 26.3, and then the short circuit current of the panel is 8.21, and then current at maximum power point is 7.61. And also here I am going to draw the PV and IV characteristics of the panel. So I am going to fix the irradiation is 400, 600, 800, and then 1000 watts per meter square, and then I am going to check the power level. When the irradiation is equal to 400 watts per meter square, the maximum power is around 81.16 watts. For 600 watts per meter square, maximum power is 131.8. For 800 watts per meter square, the maximum power is 161.5. For 1000 watts per meter square, the maximum power is around 200.1. We need to extract that maximum power from the PV panel by means of MPPT algorithm. The goal of MPPT, so we need to extract the maximum power from that PV panel based upon the condition, environmental condition, like for a particular irradiation level or particular temperature level of the solar PV cell. So we need to extract the maximum point from the PV panel. When we extract the maximum power, then we can replace the maximum power from the PV panel to the. So in order to extract the maximum power, here we have the boost converter in between solar PV array and then load. The boost converter going to be adjust the output voltage and current in order to extract the maximum power from the PV panels based upon the duty cycle generated by means of this MPPT algorithm. Here we have to measure the PV detail, and then we have to measure PV voltage current by using that voltage and current. You have to calculate the power. Here you can see that here we are calculating the power here by means of PV voltage and the PV current. These deduct change will be used to for whenever that any changes in the irradiation, what will be happen that the power of the PV panel going to be changed, the power and current of the PV panel, that should be deduct by means of that some algorithms. For that only we use this deduct change algorithm. Based upon the changes in the PV panels, we need to reset the PSO algorithm. What happened initially, it will be, for example, the PV panel operate in some operating condition like 1000 watts per meter square, 20 degrees Celsius. After some time, it changed to 800 watts per meter. So what will be happen when it changed to 800 watts per meter square? What we need to change? We need to change the duty cycle in order to extract the maximum power during that particular condition, 800 watts per meter. So for that, we need to reset the algorithm. So not to reset the PSO algorithm, we need to use this reduction change based upon the PV power and then current of the PV panel. So automatically it will be reset the PSO algorithm, and then the PSO will be adjust the duty cycle in order to extract the maximum power. And also here we use the Fuzzy MPPT. Here we need to measure the PV voltage, and then the PV voltage going to be processed via, that means compared with the maximum power point voltage. So from that we have error, and then we have change of error. The error change of error will be input for the fuzzy logic control. This fuzzy logic will be generate the duty cycle for the next stage. As well as firstly going to be generate the duty cycle. Here we need to combine these two algorithm concept. First in P. Further we are using that condition, switch condition based upon the change in power. So here you can see that we are measuring that power, and then I am going to delay the power, and then I am calculating here is change in power. Based upon change in power, here we provide some condition for switching. Based upon the change in power, we have to decide whether you have to use fuzzy or based upon the condition is fixed in the switch case. The duty cycle will be taken from the P or fuzzy logic, and then it going to be processed by a PWM generator. So this PWM generator going to be generate the pulse for that boost converter. The boost converter going to adjust the output voltage and current as well as PV voltage and current in order to extract the maximum power from the PV panel. So this is the working of this model, and here you can see that we are measuring the detail of load voltage, load current, and the load power. And also here we are measuring that PV voltage, PV current, PV power. Let we compare the result for different irradiation condition. Here already simulate the model. The model will take some time to simulate this model. Here you can see that every 2 seconds I'm going to vary the irradiation from 400, 600, 800, and 1000. Every 0.2 seconds the irradiation will be changed, and corresponding result going to be measured, and we are going to discuss now. So this is the result we are obtained from that solar PV and load. Here you can see that the PV voltage is maintained around 26 volt, right? Because you can see that for different cases, I'm going to open this IVPV characteristics. Here you can see that the voltage will be 26.51 for 400 watts per meter square. For 600 is around 26. In here for 800 is 26.45. For 1000 is around 26.3. The voltage will be is in and around 26.2 to 26.6. Here you can see that this is PV measurement. This is the load measurement. Here you can see that the PV voltage, you take the average. The PV voltage maintain around 26 volt, 26.4 volt. For changing irradiation condition, that means here the irradiation will change for every 0.2 seconds from 400, 600, 800, 1000. Right? For different irradiation condition, here you can see that the PV voltage is maintained at the constant around 26.6 volt. So it will be maintained in between these limits. So, and also you can check the load voltage. Right? What will be happen here because of change in irradiation? Here we can see that the load voltage will be vary. Because this system is operating at the standalone concept. What is happening in this model? MVBT going to adjust the duty cycle in order to maintain that PV voltage around 26.2 to 26.6 volt. When you have to maintain the voltage is in between 26.2 to 26.6 volt, what happened? We can extract the maximum power from the solar PV. This is a concept in this MPPT algorithm for the solar PV system. And also you can see that for every change in irradiation condition, the current of the PV panel also will be changed. So that is also you can check in the PV and IV characteristics also. Here you can check that one. For different condition of irradiation, you can see that the current also going to be changed. So I'm going to pick some value here. Just around 3 amps. So this is around 4.6 amps. So this is around 6 amps. This is around 7 amps. So we can see that for different irradiation condition also, you can see that it's maintained at 3 amps. It maintained around 4.5 amps. It maintained at 6.2 amps. Here you can see that it maintained around 7 or 7.2 amps. For different irradiation and also the current also maintained at the peak point current level. Here you can see that the power level would analyze the things. Here you can see that I'm going to measure the PV power. Here you can see the PV power is around 78.21 watts. That actual theoretical value is around 81. And then I'm going to change the point. Here you can see that the PV power is around 120 watts. Actual will be 128.8 something. And then I'm going to move this point here. Here you can see that the maximum power around is 161.1. The theoretical value is around 161.8 watts. And I'm going to change the point here. The maximum point is around 200 watts. Here we are getting 190 watts from the PV panel. So we are extracting the maximum power from the PV panel by means of this hybrid Fuzzy MPPT algorithm. And also you can see that the efficiency of the system. Here I am measuring that load power and then PV power, and then I'm calculating the efficiency. The efficiency of the systems around 98.41% for a particular system. This is the working of this hybrid Fuzzy MPPT for the solar PV system. Thanks for watching our videos. Kindly subscribe our channel and also click bell icon for notification about upcoming videos. Thank you so much. Bye bye.